Hi, I'm Herb Gross, and welcome once again to Gateways to Mathematics, where today we finish up the course. And that's a very nostalgic feeling for me. And I'll probably make mistakes subconsciously just to drag this thing on, so maybe the best thing for me to do today is to get right on with this while we just go through the problems to Module 12, okay? Let's go over to the board, and let's see what we can do over here. First problem says, for what value of n will, and now it's basically a two-part question. The first part says n equals 14.98376 plus 38.2367. Now what the second part is going to do, and we'll get to that in a moment, is I simply interchange the equal sign and the plus sign. Remember, we've been emphasizing in things like the commutative property for addition and for multiplication that order usually does make a difference, and this is certainly true. And you see, part A has the equal sign here and the plus sign here. Part B is going to have the plus sign here and the equal sign here, and that's going to be the difference between having an arithmetic problem and having an algebra problem. Look, in this particular problem over here, we're told that to find the value of n, all we have to do is take the two given numbers and add them. You see, what it says is n is equal to 14.98376 plus 38.2367. Well, see, now we're back to a Module 7 problem. We're just adding two decimals. With or without the calculator, the answer is 53.22046. And by the way, as trivial as it may seem, the check of this is that if you take this value, replace n by that, the resulting statement should be a true statement. Now you see in part B, this is what I meant. I've changed the equal sign and the plus sign around. So now the problem says, find the value of n if n plus 14.98376 equals 38.2367. The difference between A and B is that in A, n was all by itself on one side of the equal sign. In B, the n is mingled with numbers. And remember what the strategy is. What we want to do when we're given a problem of form B is reduce it to a problem in form of the form type in form A, well, of the form in part A, because what that does is once the n is by itself, we can solve the problem just by using the calculator. And basically the undoing method says, look, the n, what keeps the n from being by itself is the 14.98376. And since the 14.98376 is being added to the n, to undo that, we have to subtract that from the n. I'm just going to take a second here to change pens. Stay with me. Okay, there. And now what we're going to do is, since we're adding the 14.98376, we will subtract that. But you see, if we subtract it from one side of the equal sign, we also have to subtract it from the other side. Remember, this is like a scale that's balancing. Whatever we do on one side, we have to do on the other. And now again, either using the calculator or doing it out by regular Module 7 subtraction, we find that n is equal to 23.25294. Okay? And basically, if I put 23.25294 back into here, this should become a true statement. And you see, the trick here was, see what's hidden over here that you may not notice, is what we really did in a very mechanical form is we said this looks like an addition problem, but it's really subtraction, and what we're going to do is we're going to take 38.2367 and subtract 14.98376. We were doing that before this module, but in this module we now see how to handle this from a more mechanical point of view. And if you're still having trouble visualizing this, in terms of a verbal form, what does this say? It says start with n, add 14.98376, and the answer is 38.2367. See, start with n, add 14.98376, and the answer is 38.2367. See, that was arithmetic reading down like this. Algebra is we start with this. And what do? We start with the 38.2367. Now we reverse our steps. Since we had this answer after we added, to find out what we had before we added, we simply replace this step by what? Subtract 14.98376, and the answer is then n. Okay? And we're going to do this with a few other problems. Let's just get used to this. Problem number 2 says, round it off to the nearest hundredth. For what value of q will 193.92 equal 8.23 times, inside the parentheses, q plus 19.67? And I feel a little bit guilty about this problem because basically I feel by this time I want you to be using the calculator, so I took a simple concept. Well, maybe not that simple if you're not used to the algebra that we're talking about in this module, but I souped it up a little bit by putting in the kind of numbers that make it relatively inconvenient to use if you're not going to use a calculator. But the principle still stays the same. See, in fact, I will write this out in words later, but for the time being, let's see if you can see how to read this. How would you put this into words? Because we're going to do this later anyway. You look for the variable, the unknown. That's q. It's inside the parentheses. Whatever's inside the parentheses is done first. So you say what? Start with q, add 19.67. What do you do next? You have to take the 8.23 into account. And since there's no arithmetic symbol between the 8.23 and the parentheses, it's understood to be multiplication. So it's what? Start with q, add 19.67, multiply by 8.23, and the answer is 193.92. And then the question says, what was q? Now, the way to tackle this problem is we're trying to get a hold of q. And q is inside the parentheses. That protects it. See, before we can start with the q, we have to unblock the parentheses. What's blocking the parentheses? The 8.23. How is the 8.23 blocking the parentheses? It's multiplying the parentheses. How do you get rid of multiplying by 8.23? You divide by it. So as soon as I divide by 8.23, it's gone. But if I divide by 8.23 on one side, I have to divide by 8.23 on the other side. So on the left-hand side, I now have 193.92 divided by 8.23. On the right-hand side, all I have left is q plus 19.67. You may wonder why I haven't simplified this. I'm again trying to emphasize the beauty of the calculator. With the calculator, you can do all of the operations in one swell swoop, I don't know. Okay. See, now what I say is what? I want q by itself. To find q by itself, I have to subtract 19 point. See, I'm adding 19.67. So to undo adding 19.67, I'm going to have to subtract 19.67. And if I subtract 19.67 from one side, I have to subtract 19.67 from the other side, okay? And therefore, what I do over here is simply take what? 193.92, I divide that by 8.23, I subtract 19.67, and whatever I get, that's the answer to the problem. And again, if I were to do that in the verbal form, you see, what am I doing here? Let's summarize it. I'm starting with q, I'm adding 19.67, then I'm multiplying by 8.23, and I'm being told that the answer is 193.92. Okay? And basically, you see, what's happening here is what? Let's repeat this. I start with q, I add 19.67, I multiply by 8.23, and the answer is 193.92. And what I want to do is from this find the value of q. So what am I going to do? I'm going to reverse the steps in exactly the reverse order of how I got them. It's very, very crucial not to change the order of the steps. I'm going to go from here to here to here to here, but I'm going to replace multiply by divide and add by subtract. So in other words, and this is called inverting the relationship. If I want to start with the 193.92 and find q, do you see what I'm going to do? See, I'm going to start with 193.92. Instead of multiplying by 8.23, I'm dividing by 8.23. Then instead of adding 19.67, I'm subtracting 19.67, and the answer is then q. And notice that that's exactly what we did the algebraic way. We first divided both sides by 8.23, then we subtracted 19.67. And all I want to make sure you understand is that reading this one from top to bottom is the same as reading this one from bottom to top, only making sure that the word multiply has been replaced by divide and add by subtract. And the grouping symbols are very important. You see, in problem number 2, the grouping symbols enclosed the q and the 19.67. In problem number 3, I didn't put any grouping symbols in, But remember what's understood to be the case. When there are no grouping symbols, the parentheses dictate them. And you see, what this problem here says is you start with Q, then you multiply by 8.23, then you add 19.67, and if the answer is 103.92, what was Q? Now you see, in this case, the Q is inside the parentheses. Before it was inside the parentheses, but there was a different set of parentheses. Remember, what parentheses was it in the previous problem? It was inside the parentheses Q plus 19.6. See, now what's blocking the parentheses is the 19.6. How's the 19.67? How's the 19.67 blocking the parentheses? It's being added. To undo adding, you're going to subtract. So what do I do first? I first subtract the 19.67 from the 193.92. When I do that, the right-hand side still doesn't have Q by itself. Q is being spoiled by the 8.23. What's the 8.23 doing? Since there's no arithmetic symbol, it means multiplication. And to get rid of multiplying by 8.23, you're going to have to divide by 8.23. If I divide by 8.23 on one side, I divide by 8.23 on the other side, and now you see the final recipe says what? To find Q, I start with the 193.92, I subtract 19.67, then I divide 8.23. I don't know if we can get, I think we can get both of these in together. See, what I'd like you to see is what a difference the parentheses made. You see, in the first grouping, to find Q, you started with 193.92. But the first step was you divided by the 8.23. Then you subtracted the 19.67. Do you notice what happened in problem 3? You just reversed the two steps. In other words, you first subtracted the 19.67, then you divided by the 8.23. And the fact that these two answers are different shows you that the grouping makes a difference. Let's just go on and do a few more problems together. Problem number 4 says, for what value of t will 4t squared equal 1600? Problem B, if I just read it, seems to say the same thing. It says, for what value of t will 4t squared equal 1600? The thing I want you to understand is that when there are no grouping symbols, we mentioned this before, it's assumed that the square refers only to the factor immediately to the left. In other words, you read this as what? Start with t, square it, then multiply by 4, and the answer is 1600. In part B, there's the letter t. It's inside the parentheses, so everything inside the parentheses is done first. So we start with t, multiply by 4, then we square it, and the answer is 1600. I will summarize all of this in words later on. Let's just go on and see how we can tackle part A just by the mechanics of it. See, we want to get t. T is inside the parentheses, so before we do anything else, we have to unblock the parentheses. Since the 4 is blocking the parentheses, and what's the 4 doing? It's multiplying the parentheses. To undo multiplying by 4, we're going to divide by 4. But if you divide one side by 4, you have to divide the other side by 4. That gives me t squared is equal to 400. How do you unblock t squared? To unblock squaring a number, you take the square root. But if I take the square root of one side, I also have to take the square root of the other side. The square root of t squared just says t. See, if you square, then take the square root, you're back to where you started from. That was why you did this operation. And the square root of 400 means the number which, when multiplied by itself, gives you 400. Since 20 times 20 is 400, t would be 20 in that case. And if you want to see this in a verbal situation, you see what this says is, start with t, square it, multiply by 4, and the answer is 1600. So if we were to reverse our steps, what do? We start with the 1600. Now instead of multiplying by 4, we divide by 4. Now instead of squaring, we take the square root. And you see that that's exactly the same thing we did the algebraic way. I want you to really become, what word do I want to use here? Bilingual in this. To be able to go from the verbal to the algebraic to the verbal, and do it in whichever order makes the problem easier for you. Now you see part B is slightly different, but if you're nervous, or if you don't have the algebra reading comprehension, you don't see the difference between A and B. You see, the problem in part B is that t is still inside the parentheses, but now the 4 is also. In other words, what's blocking the parentheses now? The 2. And that 2 is squaring. So to undo squaring, you take the square root. You see, the square root of the square just gives me what's inside the parentheses. That's 4t. But if I take the square root of one side, I have to take the square root of the other side. What number multiplied by itself gives 1600? 4 times 4 is 16. So 40 times 40 is 1600. So that gives me that 4t is 40, and that gives me that t is 10. Why is that? Because t is supposed to stand by itself. Since it's being multiplied by 4, to undo multiplying by 4, I divide by 4. Now, sometimes people still like to work inside the parentheses first, and they say, why can't I do that? Well, you see, the reason you can't do that is that even though this looks like a 4, by virtue of the fact that it's being squared, means that it's really 4 times 4. The real number in here is that even though you only see the 4, it's really behaving like a 16. In fact, to show you what I mean from a different point of view, see, 4t squared means what? 4t times 4t. 4 times 4 is 16. T times t is t squared. So another way of writing 4t squared, see, squaring all of 4t is 16t squared. Now you can say, okay, I can divide both sides by 16. That will give me that t squared is 100. Then I'll take the square root of both sides, and that will give me that t is 10. See, there are many ways of paraphrasing this, but you've got to make sure that whatever you do conforms with reality, okay? And in fact, you know what I'd like to do? I'd like to now take this one, write it in verbal form, then juxtaposition it with this one, which is already in verbal form. In other words, A and B look alike, yet the answers were quite different. In one case, we got 20 for an answer. In the other case, we got 10. See, how would we translate this into words? It says what? Start with t, multiply by 4, square it, and the answer is 1600. See? Start with t, multiply by 4, square it, and the answer is 1600. That's part B. Part A looks like this. And do you see the difference? It looks ever so minor. But what we did is we interchanged the order of 2 steps. And it makes a difference whether first you multiply by 4 and then you square, or whether first you square and then you multiply by 4. Because if you multiply by 4 first, that's being part of what's being squared. See, just verify this for yourself. Order really does make a difference. And I just wanted you to see that. Now, problem number 5, that's kind of a nasty one. And the reason that it's nasty, especially if you haven't done Form A, see, if you've done Form A of these tests, which you should be doing, Form B, this problem in Form B isn't nasty because you've seen the nasty part in Form A. See, usually in a problem that has parts A, B, C, and D, you like to see some relationship between the parts. Many people in doing this problem, for some reason, don't see the connection between part D and parts A, B, and C. So what I'd like to do is something quite different, something I haven't done before, and since this is the last program that we're doing, I might as well try it now, because the worst that will happen is it'll stay the last show. But basically, what I'd like to do this time is to show you that in the real world, part D is the problem that you're confronted with, and A, B, and C is how you go about solving it. See, part D says this: round it off to the nearest whole number. Find a value of t for which t squared plus 3 times t will be 106. See, what does this say? Let's put this in. Doesn't this start to look a little bit heavy now? In other words, if you're not used to algebra especially, doesn't this look kind of cumbersome? Remember what we do. We look for the variable, the letter. But now there's a problem. The letter appears twice. Which one do we start with? Well, since we do everything inside the parentheses first, why don't we start with the parentheses? We locate the t inside the parentheses. What's the first thing that's happening to t? It's being squared. What are we doing next? We're adding 3. And then what are we doing? We're multiplying the whole thing by t. So in a verbal situation, this says what? Start with t, square it, add 3, multiply by, oh, that's a mistake over here. Multiply by t. See, I'm just translating from here to here. Multiply by t, and the answer is 106. So now I go about and I say, gee, let me undo this. Since the answer was 106 after I multiplied by t, before I multiplied by t, it must have been 106 divided by t. But the problem is, I don't know what t is. If I knew what t was, I wouldn't have any problem to do. You see, if this said multiply by 7, that's okay, because when I get to the 106 over here, I just divide by 7. See, 7 is called a constant. No matter what t is, 7 is still 7. The problem with t, why we call it a variable, is that what I'm dividing by over here depends on what t was chosen to be, and I don't know what t was chosen to be. So in other words, trying to use the undoing method over here becomes very, very complicated. But watch what I can do. I can say, gee, let me take a wild guess over here. I think I'll pick an easy number so the work won't be too hard. I think I'll pick 3 over here. What happens when I square 3? I get 9. If I now add 3 to it, I get 12. And if I now multiply by t, see what was t in this case? It was 3. 12 times 3 is 36. What does that tell me? Well, it tells me that I guessed wrong. If I'm looking for the number that's going to give me 106 for the answer, this one doesn't do it. But it also tells me something else. It tells me that my guess was too small, so I should try something bigger. And here's what I mean by t being a variable. Look what happens now. Suppose I try something bigger. I try 4. I square it. That gives me 16. I add 3. That gives me 19. Now I have to multiply by t. You see, my previous guess was t equals 3, so I multiplied the 12 by the 3. Now my guess is 4, so at this step, I don't multiply by 3, I multiply by 4. And what does that give me for an answer? 76. What answer am I looking for? 106. So I still guessed wrong. But is my guess too big or too small? Do you see what I'm going to do here? I'm going to keep taking guesses. And if the guess is too small, I'm going to try something bigger. If it's too big, I'm going to try something smaller. Because even if I can't undo this thing, I certainly can apply the arithmetic. In other words, even if I can't take the verbal formula and go from bottom to top, I certainly can apply the arithmetic and go from top to bottom. And by the way, that's basically what parts A, B, and C are all about. In fact, I just did part A. Part A says evaluate t squared plus 3 times t when t is 4. And all that means is every place you see a t, replace it by 4. And isn't that what I just did? 4 squared is 16, plus 3 is 19, times 4 is 76. And what does that tell me? That when I try t equals 4, I get 76. And that was too small to be the right answer. Okay? That was too small to be the right answer. In fact, what's the right answer supposed to be? 106. So that was too small. Now it says do the same thing with t equals 5. Now you see every place I see a t, I replace it by 5. See, I start with 5, I square it, that gives me 25, add 3 gives me 28, multiply by 5, that gives me 40. What happens now? I still didn't get my 106, but now this is too big. So what do I know now? I know that 4 is too small and 5 is too big. So how do I find out which whole number is closer to the right answer? I split the difference. I say, okay, let me try 4.5. And by the way, the theory stays the same here. It's just that the arithmetic gets a little bit tougher. That's what the calculator may help you with. See, now I do what? I'm going to take t squared plus 3 plus t, and every place I see a t, I'm going to replace that by 4.5. So 4.5 times 4.5 turns out to be 20.25. Then I add 3. Then I multiply that by 4.5. That's 23.25 times 4.5. Now what does that give me? That gives me 104.625. And what's that? Too big or too small? It's still too small. In other words, let me summarize what's happened. When I tried 4, t squared plus 3 times t came out to be 76. When I tried 4.5, t squared plus 3 times t came out to be 104.625. When I tried 5, t squared plus 3 times t came out to be 140. What did I want to get? I wanted to get 106. 106 fits between 104 and 140. Therefore, the value of t that I'm looking for must fit between 4.5 and 5. But if a number fits between 4.5 and 5, it's closer to 5 than it is to 4. Therefore, the answer to part D is t equals 5. You see, we had to do parts A, B, and C in order to do part D, and that's all I wanted you to see in that problem. starting with problem 6, I want to show you how algebraic equations come from formulas. Problem number 6 says, if v is equal, now how do you read this? LWH? No, whenever there are no arithmetic signs, it means multiplication. It says if v is equal to L times W times H, find the value of H if v equals 350, L equals 10, and W equals 7. You see, what we're going to do here now is what? If you look at this relationship over here, how many variables do you have? See, a variable just means a letter. You have 1, 2, 3, 4. You have 4 variables. How many inputs are we allowing so far in terms of our verbal equations? Only 1. So if I have 4 variables and I tell you the value of 3 of them, that only leaves me 1 letter left. You see, basically what I do over here is I write out that v is L times W times H. Then I take all the given information and use it. It says what? V is 350, so I replace V by 350. It tells me that L is 10. It tells me that W is 7. And H I don't know, so I still call it H. Now, what does this read now? 350 is 10 times 7 times H. Multiplication is associative, so I can multiply the 10 by the 7. That tells me that I have what? 350 equals 70H. What keeps the H from being by itself? The 70. What's the 70 doing? It's multiplying the H. How do you undo multiplying by 70? You divide by 70. But if you divide by 70 on one side, you have to divide by 70 on the other side. This cancels. 350 divided by 70 is 5, and that tells me that H is 5. And by the way, I don't have to have an answer book to tell me if this is right, because what should happen if I'm right? This times this times this should equal this. Let's try it. 10 times 7 is 70, times 5 is 350. This is a true statement. By the way, did you have to know what V, L, W, and H stood for in order to be able to do this problem? No. But what is this formula? Do you remember it? That's how you find the volume of a three-dimensional rectangle, parallelepiped they call it, if you know the length, the width, and the height. So for example, this would be how you would solve the problem if somebody said to you, the length of the parallelepiped is 10 feet, the width is 7 feet, the volume is 350 cubic feet, how much is the height? That's how you would solve that problem. See, the length equals, the volume equals the length times the width times the height. You know the volume, you know the length, you know the width, so those get replaced by numbers. That leaves H as the only letter, and now you use the techniques that we used in the first 5 problems. See, another example. If P equals 2 times, in parentheses, L plus W, find the value of L if P is 280 and W is 65. Well, what do I do over here? I take the formula and I replace the letters by their given values. P is told to me to be 280, right? So I replace P by 280. They tell me W is 65, so I replace W by 65. Now what do? I want to get a hold of the L. The L is trapped inside the parentheses, so I want to unblock the parentheses first. What's blocking the parentheses? The 2. What's the 2 doing? It's multiplying the parentheses. So to undo multiplying by 2, I divide by 2. But if I divide by 2 on one side, I have to divide by 2 on the other side. 280 divided by 2 is 140. I'm left with 140 equals L plus 65. What keeps the L from being by itself? The 65. What's the 65 doing? It's being added. So to undo adding, I'm going to subtract it. But if I subtract it from one side, I have to subtract it from the other side. 140 minus 65 is 75. 65 minus 65 is 0, so L is 75. And by the way, remember I warned you about this before. Don't go back here and decide to subtract the 65 first. Remember, the 2 is multiplying the 65. If you want to get rid of the parentheses, you can use the distributive property to say that 2 times L is 2L, and 2 times 65 is 130. In other words, you have the right to rewrite this problem as what? 280 equals twice L plus 130. See, 280 equals twice L plus 130. Now you can proceed the same way as we did before. See, to unblock the 2L, we first subtract the 130. See, not 65, the 130. That leaves us with 150 equals twice L, and if that's the case, all we do is divide both sides by 2, and we get that L is 75. Two different methods, but the same answer, isn't it? And again, do you have to know what this means physically to solve the problem? No, we just did it. What does this happen to be, however? Do you remember this one? This was the formula for the perimeter of a rectangle in terms of the length and the width. See, L stands for length, W stands for width. This says to find the perimeter of a rectangle, you add the length, the width, and then double it. So in terms of a picture over here, what this says is, suppose the width of a rectangle is 65 feet, and suppose the perimeter is 280 feet. What was the length? So the question mark here is the length. And what we're saying is, if the perimeter is 280, half the perimeter is 140, and if half the perimeter is 140, that says that the length plus the width is 140, and if the width is 65, I subtract that from the 140 to get 75, and that's the length. That's the problem we solved, even without knowing that we solved it. But if we happen to know this, it's even better. Let me show you another one with a formula, okay? Here's one that looks a little bit messier. It says if S is equal to n over 2 times A plus L, find the value of n if S is 250, A is 21, and L is 29. Now again, you may say, what in the world is related this way? I'll show you later. But the thing I want to impress upon you is you don't even have to know that to solve this problem. Because what are you going to do? Since S is 250, wherever you see S, you're going to replace it by 250. Since A is 21, wherever you see A, you're going to replace it by 21. And since L is 29, wherever you see L, you're going to replace it by 29. What could be more straightforward than that, you see? So the S gets replaced by 250. I'm looking for the value of n. I don't know what that is, so I leave that alone. The A gets replaced by 21. The L gets replaced by 29. Now I look at what's left. Remember, everything inside the parentheses gets done first. 21 plus 29 is 50, so I'm left with this. By the way, 50 is the same as 50 over 1. 2 goes into 50 25 times, so now the problem says 250 is n times 25. I want n by itself. So since the n is being multiplied by 25, I divide by 25. But if I divide by 25 on one side, I have to divide by 25 on the other side. 250 divided by 25 is 10, so n must be 10. And can we check this? If n is 10, 10 over 2 is 5. 5 times 50 is 250. Some people don't like fractions, even after my masterful presentation of it, okay? If you don't like fractions, what's nice about an equation, about an equal sign is, remember we agreed that whatever you multiply by on one side, as long as you multiply by the same thing on the other side, you don't change the value of the equation any. So what happens is you don't like the 2. Where is the 2? It's in the denominator. See, what do you multiply by to get rid of 2 in the denominator? Don't you multiply by 2 in the numerator? In other words, another alternative here is to say what I'm going to do is I will multiply the left-hand side by 2 and the right-hand side by 2. In other words, you see what I do over here is I don't like the 2 over here. I say, gee, if there was a 2 up here, these would cancel. But I can't just go putting a 2 on one side of the equation. If I put it on one side, see what was I doing? I was multiplying by 2. I have to do the same thing on the other. So what I'm doing is I'm multiplying both sides by 2. Now watch what happens. The 2 times 250 gives me 500. The 2's here cancel, and I'm left with what? N times 50? Now what can I do? If n times 50 is 500, n by itself must be 500 over 50, which would be 10. So I've got the same answer again. Just another way of doing the problem. Now, just to finish this problem off, I had told you, do you remember in our enrichment lecture, I showed you how to add the first 6 numbers and the first 100 numbers? Well, the principle behind that isn't that the numbers were consecutive. The principle behind that was there was always the same difference between 2 consecutive ones. Like in going from 3 to 7, I add on 4. In going from 7 to 11, I add on 4. In going from 11 to 15, I add on 4, right? So I'm adding on 4 each time. What that means is, to add up these numbers, I look at the first and the last. That adds up to what? 26, doesn't it? 23 plus 3 is 26. What are these 2 numbers going to add up to? Also 26, because this increased by 4, this decreased by 4. So you see, if I add the first number and the last number, That's what each pair is going to add up to. And how many pairs do I have? Since I have 6 numbers, there are 3 pairs. So a quick way of adding this is to say what? 23 plus 23 is 26. There are 3 pairs. 26 times 3 is 78. Let's check that. 3 plus 7 is 10, plus 11 is 21. 21 and 15 is 36. Well, I hate doing this stuff live if I make a mistake, golly. 36 and 19 is 55. 55 and 23 is 78. It works. So in other words, what happened over here is the formula I gave you is that A stands for the first number, L stands for the last number, and N stands for the number of terms. So you add the first number to the last number, then multiply by half the number of terms. That's the problem you were solving here. That's called how you sum an arithmetic progression. Arithmetic means each term is obtained from the previous one by always adding on the same number. In this case, we kept adding on 4s. It's not important, but I just wanted you to see that. You also may remember in the enrichment lecture that we talked about this particular formula. An object falls h feet in t seconds according to the rule h equals 16t squared. It says to the nearest tenth of a second, how long will it take the object to fall 850 feet? Now you see, we did this problem in the enrichment lecture and in the textbook, but sometimes we used easier numbers. See, for example, all I'm going to do here is what? I take this formula and I replace h by 850. The difference was, you see, when I replaced h, say, by 1600, then when I divided by the 16, I got 100. Then when I took the square root of 100 is simply 10. So the numbers worked out nice. What I want to show you is that if the numbers don't work out nicely, the mathematical principle doesn't change. What changes is the computational complicity. That's a bad one. Computational complicity. All right. You see, the theory stays the same, but the numbers get messier. That's the word I was thinking of, messier. Okay? But the calculator doesn't know messy from non-messy. It just does it for you. So watch how we tackle this problem. You see, we have 850 equals 16 times t squared. What do you want to do? You want to unblock the parentheses. Since the 16 is multiplying the parentheses, you're going to divide by 16. And if you divide by 16 on one side, you have to divide by 16 on the other side. So now what you do is you divide this by 16. That leaves you with t squared. I just took the liberty of reversing the sides of the equation. If I divide this by 16, that's called 850 divided by 16. Now, what do I want to do next? To undo squaring, I want to take the square root. See, if I take the square root of the square, that gives me the number I started with. But if I take the square root of the left-hand side, I also have to take the square root of the right-hand side. Okay? So I now take the square root of this. That looks like a mess. But on the calculator, what do? It's 850 divided by 16. Then I press the square root button. I get 7.2886. I have to remember that the time is measured in seconds. And therefore, to the nearest tenth of a second, it's going to take 7.3 seconds. And if you want the verbal interpretation of this, what are we doing? You start with the time in seconds, you square it, you multiply by 16, and now in this case the answer was not 800. That's our 1-800 number again. You always get that. That's not 800, but 850. And now what do we do here? We got the 850 after we multiplied by 16. So how would you read this verbally now? Start with the 850, then you divide by 16. That will give you 53.125. Now to undo squaring, you're going to take the square root, and that will give you the 7.2886. See, I don't care whether you go to the verbal form or not. What I do want is for you to be able to understand what you're doing and how to do it, okay? And that's all there is to that particular problem. And by the way, whenever you're in doubt, you should be able to check the answer. See, what does the answer to this problem mean? The answer to this problem says that according to the rule h equals 16t squared, the object falls 850 feet, okay? Somewhere's around what? A little over 7 seconds. So that means that at 7 seconds, it shouldn't have fallen 850 feet yet. And at 8 seconds, it should have already have fallen more than 850 feet. So what we can do for plausibility here is take 7 seconds, which should be too small to be the right answer, replace t by 7. That gives you 16 times 7 squared. That's 16 times 49. That comes out to be 784 feet. And sure enough, the thing hasn't fallen the 850 feet yet. Now you try 8 seconds. See, if I replace t by 8 in 16t squared, 8 squared is 64. 64 times 16 is 1,024. So that tells me what? The object hasn't hit the ground in 7 seconds. It must have hit the ground quite a bit before 8 seconds, because if it fell for a full 8 seconds, it would have fallen over 1,000 feet. And since 850 is between 784 and 1,024, but closer to 784, it's a reasonable guess that the amount of time it took to fall 850 feet was between 7 and 8 seconds, but closer to 7 seconds. So you're again testing the validity. And for the final problem, I want to show you that even though physical circumstances may change, sometimes two similar programs solve completely different problems. See, when I talk about the freely falling body, somehow that does not sound like this problem. This problem says the area of a circle is 725 square inches. To the nearest tenth of an inch, find the radius of the circle. Well, see, what's the relationship between the area and the radius? And how am I reminding you that you should be squaring something here? How should you know it's going to be a pi r squared formula and not a pi d formula? The way you should know is that in the wording of the problem, the dimension was what? Square inches. That means you're squaring. So someplace in the formula, something should be squared. You're multiplying something by itself. So you have the area is equal to pi times the square of r. Okay? And we always take pi to be 3.1416, unless otherwise specified in this course. Now we replace a by its given value, which is 725. So we get what? A gets replaced by 725, pi gets replaced by 3.1416, and the r squared is still in here. Now we want to find out what r is. The r squared is being multiplied by 3.1416. So the first thing we want to do is divide both sides by 3.1416. If I divide the right-hand side by 3.1416, this just drops out. If I divide 725 by 3.1416, I just get 725 divided by 3.1416. But that's not r, it's r squared. And therefore, what do I do to undo squaring r? I take the square root. But if I take the square root of one side, I also have to take the square root of the other side. So in terms of my calculator, I enter the 725, press the division sign, enter 3.1416, okay? Press the square root sign, and now I get the answer, all right? I get the answer, and what does the answer come out to be? It would have been nice if I wrote this thing down. I believe it came out to be 15.19125, which rounds off to 15.2. And you may wonder, how did I rapidly do this in my head? I fortunately happen to have written it down on the next third of the blackboard, so we bailed out just in the nick of time. But here's the thing I thought I'd like to show you about this problem. You see, in doing this problem, what did you do? You started with r, then you squared it to get r squared, then you multiplied by 3.1416 to get the final answer. What were we doing in the distance, the freely falling body problem? Instead of starting with r, we started with t. Okay, let's put a t over here. Who cares what letter we call the input by? We still started with picking a number. What was the next step we did? We squared. We squared. Now, the only other difference was, instead of multiplying by 3.1416, we multiplied by 16. But do you notice how the problem was very, very similar? In other words, in terms of a program, what did we do? We took an input, we squared it, and we multiplied it by a constant. In one case, the constant was 16. The other case, the constant was 3.1416. But basically, the idea stayed the same. And again, there's where we got the answer from. And the answer was 15.2 inches. And by the way, to check this out, you know that the area of a circle is the square of the radius times pi. We're taking pi to be 3.1416. So if 15.2 is the right answer, first of all, what should happen? I could take 15.2, square it, multiply by 3.1416, and that should give me something very close. considering rounding off and everything, to 725. But if I wanted a quicker check, what do? I take 15, I square it, I multiply by 3.1416. That gives me 706.86, which is too small to be the right answer. Then I try 16, I square that, multiply that by 3.1416. That gives me 804.2496. That's too big to be the right answer. So whatever the right answer is, see, if I didn't know algebra, I could have kept going by trial and error till I tried. See, again, it's like Goldilocks and the Three Bears. I tried 15, but that was too small. I tried 16, but that was too big. So the right answer had to be between 15 and 16, and because 725 is closer to 706 than to 804, it's between 15 and 16, but closer to 16. Okay? And I guess that brings us officially now to the end of the course. It has been a tremendous pleasure for me to present this material for you. I do hope, I sincerely hope, that we will see each other again in the future, doing one course or another. And as I say, it's been a real pleasure. Take care of yourselves. God bless.